What if I told you that you're currently sitting on a piece of rock that once shared a border with Antarctica? That the ground beneath your feet has traveled thousands of miles across the Earth's surface like a massive slow-motion conveyor belt? And here's the mind-blowing part. If you could travel back 250 million years, you could literally walk from New York to Morocco without getting your feet wet. Welcome to the world of Pangea. But forget everything you think you know about this ancient supercontinent. Because what I'm about to show you will completely shatter your understanding of not just Earth's past, but the very ground you're standing on right now. Picture this. Earth as a single, massive landmass surrounded by one enormous ocean. No Atlantic, no Pacific as we know it. Just one supercontinent where dinosaurs could theoretically walk from what we now call Alaska to South Africa without ever seeing the sea. But here's where it gets absolutely insane: the climate, the life forms, the very physics of how weather worked were so alien that our planet might as well have been an entirely different world. And the most shocking revelation of all? We're heading toward another Pangea. Right now, as you watch this video, the continents are moving toward their next inevitable collision. Your great-grandchildren many generations removed might live on Pangea Proxima, the next supercontinent. That's already forming beneath our feet. But before I blow your mind with what Pangea was really like, I need you to do something. Hit that like button if you're ready to have your worldview completely transformed. Subscribe for more reality-shattering content. And tell me in the comments, what country are you watching from? And what time is it where you are? Because by the end of this video, you're going to see your location on Earth in a completely different light. Let's start with what seems like a simple question. How do we even know Pangea existed? The answer involves one of the greatest detective stories in scientific history, and it began with a meteorologist who was ridiculed by the entire scientific community. In 1912, Alfred Wegener proposed something so outrageous that geologists literally laughed him out of conferences. He suggested that continents moved, not just a little bit, but thousands of miles across the Earth's surface. His evidence? Look at a world map. South America and Africa fit together like puzzle pieces. But it wasn't just the shapes, it was the rocks, the fossils, the ancient climate evidence. Wegener found identical fossils of the ancient reptile Mesosaurus in both South America and Africa, a creature that couldn't swim across oceans. He discovered matching rock formations, like the Appalachian Mountains in North America, connecting perfectly with the Scottish Highlands. The evidence was overwhelming, but there was one massive problem. Wegener couldn't explain how continents moved. For 50 years, the scientific community dismissed continental drift as impossible. Then, in the 1960s, scientists made a discovery that changed everything. Deep beneath the ocean floor, they found something that shouldn't exist: massive underwater mountain ranges with volcanic activity, creating new ocean floor while simultaneously destroying old floor elsewhere. Think of it like a giant conveyor belt system. Hot material rises from deep within the Earth, creates new ocean floor and mid-ocean ridges, then pushes older ocean floor toward the continents where it gets recycled back into the Earth's interior. This process, plate tectonics, finally explained how continents could move. But here's what will blow your mind. The speed at which continents move is roughly the same rate your fingernails grow, about 2 to 4 centimeters per year. That seems impossibly slow, but over millions of years, it adds up to thousands of miles of movement. Now, imagine running this conveyor belt system in reverse. Wind back the clock 300 million years, and you'd watch the Atlantic Ocean slowly shrink and disappear. You'd see North America sliding eastward, colliding with Europe and Africa. South America would crunch into Africa's west coast. India would detach from Antarctica and begin its epic journey northward toward Asia. By about 250 to 300 million years ago, Virtually all of Earth's land masses had assembled into one colossal supercontinent. But calling it just one continent doesn't capture the true scale of this thing. Pangea stretched from pole to pole and covered about 1/3 of the Earth's surface. The remaining 2/3 was covered by a single massive ocean called Panthalassa, literally meaning all ocean. But here's where the story takes a surprising twist. Pangea wasn't just big, it was profoundly different from anything we see on Earth today. The physics of how weather systems worked, how heat moved around the planet, how life could survive, all of it operated under completely alien rules. Think of it like this. Imagine if all the world's land was compressed into an area roughly the size of Asia, but stretched from the North Pole to the South Pole. The interior of this massive continent was so far from any ocean that it created the most extreme continental climate Earth has ever experienced. We're talking about temperature swings that would make Death Valley look like a tropical resort. And this is just the beginning. What I'm about to show you about Pangea's climate, its life forms, and its ultimate destruction will completely rewrite your understanding of how dynamic and violent our seemingly stable planet really is. Here's what will blow your mind about Pangea's climate. It was simultaneously the most extreme and most stable climate system Earth has ever had. How is that possible? Let me paint you a picture that will make you grateful you live in the modern world. Imagine a landmass so massive that its interior regions were over 2,000 miles from the nearest ocean. In our modern world, the farthest you can get from an ocean is about 1,500 miles in Central Asia, and even that creates extreme continental conditions. But in Pangea, vast areas were twice that distance from moderating ocean influences. The result was a climate that makes our most extreme weather look gentle. Summers in Pangea's interior regularly reach temperatures of 50 to 60 degrees Celsius. That's 122 to 140 degrees Fahrenheit. But here's the kicker. Winters could plummet to minus 40 degrees Celsius in the same locations. We're talking about annual temperature swings of 100 degrees Celsius in some regions. But the truly alien aspect wasn't just the temperature extremes. It was the complete absence of seasonal rainfall in vast interior regions. Dr. Paul Olson from Columbia University has studied ancient lake deposits from Pangea and found evidence of mega monsoons. Rainfall patterns so extreme, they created alternating periods of catastrophic flooding, followed by decades-long droughts. Think of it like this. Imagine if the entire American Midwest experienced the rainfall patterns of the most extreme parts of the Sahara Desert, combined with temperature swings that would make Siberia look tropical. That was daily life in interior Pangea. Now, you might think, surely life couldn't survive in such extreme conditions. But here's where Pangea throws us another curveball. Some of the most successful and diverse ecosystems in Earth's history thrived during the Pangean period. How? The secret lies in understanding that while Pangea's interior was hostile, its coastal regions experienced something unprecedented in Earth's history, the ultimate tropical paradise. With most of the world's landmass concentrated in tropical and subtropical latitudes, and with sea levels much higher than today, coastal Pangea was like an endless chain of tropical islands. But on a continental scale. Dr. Christopher Scotese, a paleoclimatologist at Northwestern University, has used computer models to reconstruct Pangea's climate, and his findings are staggering. The coastal regions of Pangea experienced year-round temperatures similar to modern-day Hawaii, but extending across areas larger than modern North America. But here's what really gets fascinating, and this will change how you think about Earth's climate system forever. Pangea's existence fundamentally altered how heat moved around the planet. In our modern world, ocean currents like the Gulf Stream transport enormous amounts of heat from the equator toward the poles. But with Pangea blocking these circulation patterns, Heat transport worked completely differently. Instead of ocean currents, the primary mechanism for moving heat around Pangea was something called continental-scale convection cells, essentially. Massive atmospheric rivers that created predictable but extreme weather patterns. Imagine hurricanes the size of Texas, forming regularly and following the same paths, year after year for millions of years. This created something unprecedented in Earth's climate history. Extreme local conditions within an overall, stable global system. While individual regions of Pangea experienced violent weather, the overall climate pattern remained remarkably consistent for tens of millions of years. And here's a mind-bending thought. This stability is exactly what allowed life to evolve in ways that would be impossible in our modern, more variable climate. The extreme conditions weren't random chaos. They were predictable extreme conditions that life could adapt to over geological timescales. But the most shocking revelation about Pangea's climate is still coming. Because what ultimately destroyed this stable system wasn't gradual change. It was one of the most catastrophic events in Earth's history. And it holds terrifying lessons for our modern climate crisis. What if I told you that Pangea was home to creatures so bizarre and successful that they make modern ecosystems look simple by comparison? And here's the mind-blowing part. Some of these ancient life forms used survival strategies that are only now being rediscovered by cutting-edge biotechnology. Let's start with the most alien aspect of Pangean life, the forests. Forget everything you know about what forests look like, because Pangean forests were dominated by plants that most modern humans have never seen outside of a botanical garden. Massive tree ferns, towering horsetails, and scale trees that could reach heights of 40 meters. Dr. William D. Michel from the Smithsonian has spent decades studying Pangean plant fossils, and his discoveries reveal something extraordinary. These ancient forests were the most efficient carbon storage systems in Earth's history. The scale, trees called lepidodendron, didn't just grow tall. They grew fast and in incredible density. A single square kilometer of Pangean forest could contain more biomass than most modern rainforests. But here's where it gets truly alien. These forests operated on completely different biological rules. Most Pangean trees reproduced only once, in their lifetime growing rapidly to enormous sizes, then releasing millions of spores in a single reproductive event before dying. Imagine entire forests synchronized to reproduce and die simultaneously, creating massive die-offs followed by explosive regrowth. This reproductive strategy created something unprecedented. Forests that could rapidly colonize new areas, but also created massive accumulations of dead plant material. And here's the kicker. This dead plant material became the coal deposits that powered the Industrial Revolution. When you burn coal, you're literally burning the remains of Pangean forests. Now let's talk about the animals, because this is where Pangea gets really mind-bending. The dominant land animals weren't dinosaurs. Those came later. Instead, Pangea was ruled by therapsids, the distant ancestors of mammals, and they had evolved survival strategies that seem like science fiction. Take Lystrosaurus, a pig-sized herbivore that became the most successful land animal in Earth's history. Dr. Jennifer Boda from the University of the Witwatersrand has studied Lystrosaurus fossils and discovered something incredible. This animal survived the greatest mass extinction in Earth's history by essentially hibernating for months at a time, slowing its metabolism to near-death levels. Think of it like this. Imagine if modern mammals could survive by entering a state similar to suspended animation, reducing their metabolic needs by 95%. Lystrosaurus could do this routinely, allowing them to survive the extreme seasonal variations of Pangean climate. But the truly shocking discovery about Pangean life involves the marine ecosystems. While we focus on the land animals, the real evolutionary innovations were happening in Panthalassa, the massive ocean surrounding Pangea. Dr. Eric Sperling from Stanford University has studied marine fossils from this period and found evidence of the first truly complex marine ecosystems. Underwater forests of crinoids, sea lily, that created three-dimensional reef systems more complex than modern. Coral reefs. These underwater forests were home to creatures that challenge our understanding of animal intelligence. Nautiloids, relatives of modern octopuses, grew to sizes larger than modern whales and showed evidence of complex social behaviors. Some species appear to have used tools and may have had cognitive abilities rivaling modern dolphins. But here's what will really blow your mind. Recent genetic analysis suggests that many of the biochemical innovations we see in modern organisms actually first evolved during the Pangea period. The ability to produce antifreeze proteins, extreme temperature tolerance, even the precursors to echolocation, all of these appeared first in Pangea species as adaptations to the continent's extreme conditions. And this leads to a profound realization. The extreme conditions of Pangea weren't just a hostile environment that life barely survived. They were an evolutionary laboratory that pushed life to develop capabilities that still benefit organisms today. Dr. Douglas Irwin from the Smithsonian has called the Pangea period evolution's greatest experiment, because the combination of extreme conditions and continental-scale ecosystems allowed for evolutionary innovations that simply couldn't happen in smaller, more isolated environments. But the most incredible aspect of Pangean life was its interconnectedness. Because all land masses were connected, species could spread across vast distances, creating the first truly global ecosystems. A species that evolved in what we now call Siberia could migrate to what we now call South Africa, sharing genetic innovations across the entire planet. This global connectivity created evolutionary feedback loops that accelerated the development of complex traits. It's as if the entire planet became a single laboratory for life's most ambitious experiments. And this sets up the most mind-bending revelation of all. What ultimately ended this incredible period wasn't gradual change, but a catastrophe so complete that it makes the dinosaur extinction look like a minor setback. Here's something that will completely reframe how you think about Earth's stability. Pangea didn't just break apart through gentle geological processes. It was literally torn apart by one of the most violent events in our planet's history. And the forces that destroyed Pangea are still active today, shaping our modern world in ways you've never imagined. The breakup of Pangea began about 200 million years ago with something called the Central Atlantic Magmatic Province and calling it a volcanic event is like calling a nuclear explosion a small fire. This was geological violence on a scale that defies comprehension. Dr. Paul Olson from Columbia University has studied the rock layers from this period, and what he found reads like a disaster movie script. Imagine volcanic eruptions that lasted for 600,000 years continuously. Not occasional eruptions, continuous volcanic activity across an area larger than modern Europe, pumping out lava flows that in some places are over 6 kilometers thick. To put this in perspective, the 1815 eruption of Mount Tambora caused global climate change for several years from a single mountain. The Central Atlantic Magmatic Province was like having thousands of Tamboras erupting simultaneously for more than 500,000 years. But here's what makes this truly mind-bending. This wasn't just happening in one location. As Pangea began to split apart, similar massive volcanic events occurred along multiple fracture lines. The Koru-Ferrer, large igneous province in southern Pangea, the Siberian traps in the north. It was as if the entire supercontinent was being torn apart by volcanic forces of unprecedented scale. Dr. Andrea Marzoli from the University of Padova has calculated that these volcanic events released more carbon dioxide into the atmosphere than humans have released in our entire industrial history, but they did it in just a few thousand years. The result was catastrophic. Global warming that killed off about 76% of all species on Earth. Now think of it like this. Imagine if every volcano on Earth erupted simultaneously and kept erupting for 600,000 years, while releasing greenhouse gases at a rate thousands of times faster than modern human activity. That's what ended the age of Pangea. But here's where the story takes an incredible turn. This destruction wasn't just random geological violence. Recent research by Dr. Lauk van der Cluyssen from Drexel University has revealed that the breakup of Pangea followed precise patterns related to the Earth's deep interior structure. The volcanic eruptions occurred along lines of weakness that had been predetermined by the way the supercontinent assembled in the first place. In other words, Pangea carried the seeds of its own destruction from the moment it formed. The same forces that brought all the continents together created stress patterns that would inevitably tear them apart. And this leads to a profound realization. Supercontinents, like Pangea, are inherently unstable. They can't exist permanently because their very size creates internal stresses that must eventually be released through catastrophic breakup events. But the breakup of Pangea created something unprecedented in Earth's history: the modern ocean system. As the Atlantic Ocean opened up, it fundamentally changed how the planet's climate system operates. The new ocean basins created circulation, patterns that distribute heat around the globe more efficiently than ever before in Earth's history. Dr. Christopher Scotisi's climate models show that the breakup of Pangea led directly to the relatively stable, mild climate that has characterized most of the last 100 million years. The climate that allowed for the evolution of flowering plants, modern ecosystems, and ultimately, complex life forms like ourselves. Here's what will blow your mind. We're living in the Pangea diaspora. The scattered remnants of the supercontinent are still moving away from each other. And this movement is what maintains our planet's current climate stability. But here's the terrifying part. This stability isn't permanent. The same forces that tore Pangea apart are now driving the continents toward their next collision. The Atlantic Ocean, which began forming when Pangea split apart, is already beginning to close as the Pacific Ocean shrinks. Dr. Christopher Scotisi has calculated that in about 250 million years, the continents will assemble into a new supercontinent, Pangea Proxima. And when that happens, the same cycle of extreme climate, evolutionary innovation, and eventual catastrophic breakup will begin again. This means that the stable, moderate climate that has allowed human civilization to develop is just a temporary phase in now Earth's long-term cycle of supercontinent, formation and destruction. And this sets up the most mind-bending question of all. If supercontinents are inherently unstable and create extreme conditions, why does Earth keep forming them? The answer involves forces so deep within our planet that we're only beginning to understand them. What if I told you that the formation and destruction of supercontinents like Pangea is connected to a process so fundamental that it controls not just Earth's surface, but the very existence of our planet's magnetic field, its atmosphere, and ultimately, its ability to support life? Welcome to the mind-bending world of mantle convection, the engine that drives everything. Deep beneath your feet, about 2,900 kilometers down, lies one of the most alien environments in our solar system, the boundary between Earth's solid mantle and its liquid outer core. The temperature here is about 4,000 degrees Celsius, nearly as hot as the surface of the sun. And it's here that the ultimate fate of continents is decided by forces that operate on timescales that make human civilization look like a brief flicker. Dr. Carolina Lithgow-Bertoloni from UCLA has used supercomputer simulations to model mantle convection, and her findings reveal something extraordinary. The formation of supercontinents like Pangea isn't random. It's part of a precise, predictable cycle driven by the way heat moves through the Earth's interior. Think of it like this. Imagine the Earth's mantle as a massive lava lamp. But instead of taking minutes to form convection patterns, it takes hundreds of millions of years. Hot material rises from the core mantle boundary, reaches the surface, cools, and then sinks back down, creating massive circulation cells that span thousands of kilometers. Here's where it gets mind-bending. These circulation cells are so large and powerful that they can literally drag entire continents across the Earth's surface. When multiple continents get caught in converging circulation cells, they're pulled together to form supercontinents. When the circulation pattern changes, the supercontinents get torn apart. But Dr. Lithgow Bertellini's research revealed something even more incredible. This process is self-regulating. When a supercontinent forms, it acts like an insulating blanket on the Earth's surface, trapping heat in the mantle beneath it. This trapped heat eventually builds up enough pressure to create the massive volcanic events that tear the supercontinent apart. It's like the Earth has a built-in thermostat that prevents any single continental configuration from lasting too long. The planet literally regulates its own surface temperature by periodically rearranging its continents. Now, here's what will completely blow your mind. Recent research by Dr. Zheng Xiang Li from Curtin University suggests that this supercontinent cycle is intimately connected to the evolution of complex life on Earth. The extreme conditions during supercontinent formation push evolution to develop new survival strategies, while the moderate conditions during breakup periods allow these innovations to spread and diversify. In other words, the cycle of supercontinent formation and destruction isn't just a geological process, it's evolution's pacemaker, regularly creating the conditions necessary for major evolutionary leaps. But the implications go even deeper. Dr. Peter Cawood from the University of St. Andrews has proposed that the supercontinent cycle is what keeps Earth habitable over geological time scales. Without this cycle, our planet would either become too hot if continents stayed dispersed, or too cold if they stayed assembled to support complex life. Think about this. The same process that created the extreme conditions of Pangea is also what maintains Earth's long-term climate stability. It's as if our planet has evolved a sophisticated climate control system that operates over hundreds of millions of years. And this leads to a profound realization about our place in the universe. Earth isn't just a random rocky planet that happens to support life. It's a finely tuned system where geological and biological processes work together to maintain habitability over vast timescales. But here's the truly mind-bending part. We're not just passive observers of this system. Human activity is now happening so fast and on such a large scale that we're beginning to influence geological processes. Our carbon emissions are changing the planet's climate faster than many geological processes can respond. Dr. Jan Zalesevich from the University of Leicester has argued that human activity is creating a new geological epoch, the Anthropocene, where human influence rivals geological forces in shaping Earth's surface and climate. This means we're living through a unique moment in Earth's history, a time when biological processes, human civilization, are operating fast enough to compete with the geological processes that have controlled the planet for billions of years. And this sets up the most important question of all as we hurtle toward the formation of the next supercontinent. What role will human civilization play in shaping Earth's future? Will we be passive passengers on the geological roller coaster, or active participants in designing our planet's destiny? The answer might surprise you, because it involves understanding something that most people never think about: the deep connection between human consciousness and the very geological processes that created our world. Here's something that will fundamentally change how you see yourself and your place in the universe. Every atom in your body has been on an epic journey through multiple supercontinents, and the very elements that make you conscious were forged in processes directly connected to the formation and destruction of worlds like Pangea, Let me blow your mind with a concept that connects geology, biology, and consciousness in ways that most scientists are only beginning to understand. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of these atoms have been recycling through Earth systems for billions of years. And here's the kicker. Many of them were locked in the rocks of Pangea. Dr. Robert Hazen from the Carnegie Institution has calculated that the average atom in your body has been through the rock cycle, the process of rock formation, weathering, and reformation, about 20 times since Earth formed. This means that atoms currently in your brain have likely been part of ancient mountains, deep ocean sediments, and yes, the rocks of Pangea itself. Think about this. When you think a thought, you're using neural networks built from atoms that once formed part of the supercontinent. Your consciousness is literally built from the recycled materials of ancient worlds. But the connection goes deeper than just atomic recycling. Recent research by Dr. Nick Lane from University College London has revealed that the evolution of complex consciousness required specific geochemical conditions that were intimately connected to the supercontinent cycle. Here's what's mind-bending. The evolution of complex cells with nuclei, eukaryotes, appears to have been triggered by changes in ocean chemistry that occurred during the assembly and breakup of ancient supercontinents. The extreme conditions created by supercontinent formation led to changes in atmospheric oxygen levels, which in turn drove the evolution of more complex cellular machinery. Dr. Lane's research suggests that consciousness itself, the ability to process information in complex ways, evolved as a response to the challenging and variable environments created by the supercontinent cycle. In other words, your ability to think and be aware of yourself exists because of the same geological processes that created Pangea. But here's where it gets truly mind-bending. Human consciousness has now evolved to the point where we can understand and potentially influence these same geological processes. We've become the first species in Earth's history that can consciously participate in the forces that shape our planet's destiny. Dr. Peter Ward from the University of Washington has proposed that we're witnessing the emergence of something unprecedented in Earth's history. A geological intelligence, a form of consciousness that operates on planetary scales and geological time scales. Think about it. Through science, we can now predict how continents will move over the next few 100 million years. Through technology, we're beginning to influence global climate and atmospheric composition. We're developing the capability to literally reshape our planet's surface through massive engineering projects. This means that when the next supercontinent, Pangea Proxima, begins to form, it might not be entirely a natural process. Human civilization, if it survives and continues to develop, might be actively involved in guiding how the continents come together. Dr. Michio Kaku from City College of New York has speculated that sufficiently advanced civilizations might actually engineer supercontinent formation to create more stable, habitable planetary configurations. Instead of being victims of geological forces, we might become geological engineers. But here's what's truly profound. This isn't science fiction. It's the logical extension of processes that are already underway. We're already influencing geological processes through climate change, mining, and massive construction projects. We're just doing it unconsciously and chaotically. The question is, will we develop the wisdom and cooperation necessary to consciously guide geological processes, or will we remain unconscious participants in forces we don't fully understand? And this leads to perhaps the most mind-bending realization of all. Your individual consciousness is part of a larger process of planetary awakening. Every time you learn something about Earth's deep history, every time you marvel at the incredible journey that brought continents together and tore them apart, you're participating in the planet's growing self-awareness. Dr. James Lovelock's Gaia hypothesis suggests that Earth functions as a single, self-regulating system. But what if that system is now developing something analogous to consciousness through the emergence of intelligent life, capable of understanding and potentially guiding its own geological processes? This would mean that your fascination with Pangea, your sense of wonder at the scale of geological time, your growing understanding of how continents move and climates change, all of this is part of Earth, developing the ability to consciously direct its own evolution. You're not just learning about Pangea. You're participating in a process that might ultimately lead to conscious planetary engineering on a scale that would make the formation of the original supercontinent look like a small construction project. What if I told you that right now? As you're watching this video, you're experiencing something that no creature in Pangea's history ever could. The ability to simultaneously exist at multiple points in geological time through the power of scientific understanding. And this ability might be the key to humanity's survival as we approach the next supercontinent formation. Here's a mind-bending thought experiment that will change how you see time itself. Imagine you could take a Pangean creature, say, one of those massive Dimetrodon with their distinctive sail fins, and give it the ability to understand deep time. How would its behavior change if it knew that the stable climate it experienced was just a temporary phase in a vast cycle of continental assembly and destruction? This isn't just philosophical speculation. It gets to the heart of what makes human consciousness unique in Earth's history. We're the first species that can simultaneously exist in the present moment while being fully aware of past and future geological processes that operate on timescales millions of times, longer than individual lifetimes. Dr. Marcia Bornerod from Lawrence University has written extensively about what she calls timefulness, the ability to think and act across multiple temporal scales simultaneously. She argues that this capacity isn't just an intellectual curiosity. It's an evolutionary adaptation that might be crucial for long-term species survival. Think about it. Every other species that lived through major geological transitions, including the breakup of Pangea, experienced these changes as random catastrophes. They had no way to anticipate, prepare for, or potentially guide these planetary scale transformations. But we do. When the Siberian traps erupted and began pumping massive amounts of carbon dioxide into the atmosphere, ending the Pangean period, the creatures living through that experience had no framework for understanding what was happening. To them, it was just an endless series of disasters: volcanic eruptions, climate change, ecosystem collapse. But you, sitting here in the 21st century, can understand that entire catastrophic sequence as part of a larger, predictable pattern of supercontinent formation and destruction. You can see it not as random chaos, but as part of the Earth system's natural regulatory mechanisms. This temporal perspective gives humanity something unprecedented: the potential for geological scale wisdom. We can make decisions today based on understanding of processes that will play out over hundreds of millions of years. Dr. Kevin Anderson from the University of Manchester has studied how human decision-making changes when people truly internalize geological timescales. His research shows that people who develop deep time awareness tend to make radically different choices about everything from career paths to environmental behavior. Here's what's fascinating: when people really grasp that they're living through a brief interglacial period between ice ages, during a temporary phase of continental separation that will eventually lead to another supercontinent formation, they often report a profound shift in their sense of purpose and priority. Some experience what psychologists call cosmic anxiety, a sense of meaninglessness in the face of vast geological time. But others experience the opposite, a sense of profound responsibility and connection to processes much larger than individual human concerns. And this second response might be evolutionarily crucial. Dr. David Christian from Macquarie University founder of the Big History movement, argues that the ability to think across vast timescales is humanity's primary survival adaptation. In his view, we evolved big brains not primarily to solve immediate problems, but to navigate complex, long-term challenges that require understanding multiple systems, operating on different timescales. This capacity is being tested right now. Climate change, biodiversity loss, resource depletion, all of these are challenges that require simultaneous awareness of human timescales, years to decades, and geological timescales, millennia to millions of years. Species that can't think across these multiple temporal dimensions are likely to make decisions that are adaptive in the short term but catastrophic in the long term. But here's what's truly mind-bending. If humanity develops the ability to consciously navigate geological timescales, we might become something unprecedented in Earth's history, a species that can consciously participate in and potentially guide the supercontinent cycle itself. Dr. Freeman Dyson from the Institute for Advanced Study has speculated about geological engineering, the conscious manipulation of continental drift patterns to maintain optimal climate conditions over hundreds of millions of years. While this might sound like science fiction, the basic principles are already understood, and the technology for small-scale geological manipulation already exists. Imagine humanity 50 million years from now, actively managing continental positions to maintain stable climate conditions as the next supercontinent begins to form. Instead of experiencing supercontinent assembly as a catastrophic event, like the organisms of Pangea did, future humans might guide the process to create optimal conditions for continued civilization and biological diversity. This would represent something completely new in Earth's history: conscious participation in geological processes rather than passive subjugation to them. And this leads to the most profound question of all. If consciousness can evolve to operate on geological timescales, what does that mean for the nature of consciousness itself? Are we witnessing the emergence of a form of awareness that transcends individual organisms and begins to operate at the level of planetary systems? Now I want you to step outside for a moment. Seriously, pause this video, go outside, and put your hand on the ground. Feel the soil, the rock, the earth beneath your feet. What you're touching right now is your personal connection to one of the most epic journeys in the history of the universe. That ground beneath your hand has traveled thousands of miles from its original position when Pangea existed. If you're in North America, the rock you're touching was once connected to Africa. If you're in Europe, you're standing on ground that was once part of a massive desert in the interior of the supercontinent. If you're in South America, the earth beneath your feet shared borders with Antarctica and Australia. But here's what will blow your mind. It's not just that the ground has moved. You are personally connected to every single process that shaped that ground over the past 250 million years. Let me show you how the oxygen you're breathing right now was partly produced by the forests of Pangea, those massive scale trees and giant ferns that dominated the supercontinent pumped oxygen into the atmosphere as they photosynthesized. Some of the O2 molecules entering your lungs right now have been cycling through Earth's atmosphere since the Pangean period. The carbon dioxide you're exhaling includes carbon atoms that were once locked in Pangean limestone, released during the massive volcanic eruptions that tore the supercontinent apart, absorbed by plants that evolved after Pangea's destruction, and have been cycling through living organisms for hundreds of millions of years. Think about this. Every breath you take connects you directly to the atmospheric composition created by Pangea's formation and destruction. You're not just learning about ancient history. You're literally breathing ancient history. But the connection goes even deeper. Dr. Bruce Railsback from the University of Georgia has traced how elements move through the Earth system over geological time, and his research reveals something mind-bending. The calcium in your bones was likely once part of Pangean limestone. The iron in your blood may have been dissolved from rocks that formed when Pangea's interior experienced those extreme temperature swings. Here's what's truly profound. Your body is built from the recycled materials of the supercontinent. You are literally made of Pangea. But this isn't just poetic metaphor. It has practical implications for how you see your place in the world. When you understand that your physical body is composed of materials that have been cycling through Earth's systems for hundreds of millions of years, it changes your relationship to the planet in fundamental ways. Dr. Tyler Volk from New York University studies what he calls meta-patterns, recurring patterns that appear at different scales throughout nature. One of the most profound meta-patterns he's identified is the way individual organisms are always part of larger cycling systems. You don't just live on Earth. You are Earth, temporarily organized into a conscious thinking form. This realization transforms how you see environmental issues. Climate change isn't something happening to a planet separate from you. It's something happening to the larger system that you're an integral part of. The carbon cycle that's being disrupted by human activity is the same cycle that connects you to the ancient forests of Pangea. When you drive a car and release carbon dioxide, you're participating in the same atmospheric processes that once regulated Pangea's climate. When you eat food, you're accessing solar energy captured by photosynthesis, the same process that created the massive coal deposits we burn today, which are the fossilized remains of Pangean forests. But here's what's most mind-bending. Your consciousness, your ability to understand these connections, is itself part of the Earth system's evolution. Dr. Eric Chasen from Harvard has calculated that the energy flows through your brain as you process information are comparable to the energy flows through some geological systems. In other words, your thoughts about Pangea are happening at energy densities that rival some of the physical processes that created and destroyed the supercontinent. Your consciousness isn't separate from geological processes. It's the latest evolution of the same energy flows that have been shaping the planet for billions of years. This means that when you feel awe looking at a mountain range, or wonder thinking about deep time, or connection contemplating your atomic heritage from ancient worlds, you're not just having subjective experiences. You're participating in the universe, becoming aware of itself through geological processes. And this awareness brings responsibility. You're living at a unique moment in Earth's history when the cycling systems that connect you to Pangea are being rapidly altered by human activity. The stability that has characterized the post-Pangean period, the moderate climate that allowed human civilization to develop, is being challenged by changes happening faster than most geological systems can adapt to. But you're also living at the first moment in Earth's history when a species has the knowledge and potentially the wisdom to consciously participate in planetary scale processes. Your understanding of Pangea isn't just intellectual curiosity. It's part of developing the consciousness necessary to navigate the next phase of Earth's evolution. Here's what will completely reframe how you see the future. We're not just heading toward another supercontinent. We're heading toward the first consciously guided supercontinent in Earth's history. And the choices we make in the next few decades will determine whether that process leads to unprecedented flourishing or catastrophic collapse. Dr. Christopher Scotisi's models of Pangea Proxima, the next supercontinent predicted to form in 250 million years, show a world that could be either a paradise or a hellscape, depending on how atmospheric composition and ocean circulation patterns develop. But here's what's mind-bending. Unlike previous supercontinent formations, this one will be influenced by the choices of a conscious, technological species. Think about the incredible responsibility this represents. Every decision about energy, systems, climate policy, biodiversity conservation, and technological development is essentially a vote on what kind of planet we want to create over geological timescales. But to understand the full magnitude of this responsibility, we need to grasp something that most people never consider. The next supercontinent formation has already begun. The processes that will create Pangea, Proxima are active right now. The Pacific Ocean is shrinking at about 2 to 3 centimeters per year as the Pacific Plate gets subducted beneath surrounding continental plates. The Atlantic Ocean is still expanding, but that expansion is slowing. Australia is racing northward toward Asia at about 7 centimeters per year. Breakneck speed in geological terms. Dr. Dietmar Müller from the University of Sydney has used computer models to track these movements. And his predictions are stunning. Australia will collide with Southeast Asia in about 50 to 100 million years. The Americas will eventually swing around to collide with the combined Australia-Asia landmass. Africa will continue its slow collision with Europe, eventually creating mountain ranges that will dwarf the current Alps. But here's where it gets truly mind-bending. By the time these collisions occur, human civilization, if it survives and continues to develop, will have had 2,500 times longer than all of recorded history to develop technological capabilities. We're talking about a span of time that makes the difference between the stone age and the space age look like a brief moment. What kind of technological capabilities might exist over such timescales? Dr. Michio Kaku has speculated about type 2 civilizations, species that can harness the entire energy output of their star. By the time Pangea Proxima begins to form, humanity might have energy resources that dwarf anything we can currently imagine. This could mean that instead of being passive victims of continental collision, future humans might actively guide the process. Imagine using directed energy to slow or accelerate tectonic plate movements, or engineering massive atmospheric modifications to maintain optimal climate conditions as continents converge. But here's what's truly profound: the decisions we make in the next 50 to 100 years will largely determine whether humanity survives long enough to face these geological scale challenges. Climate change, biodiversity loss, resource depletion, and potential technological risks like artificial intelligence or nanotechnology could end human civilization long before the next supercontinent begins to form. Dr. Nick Bostrom from Oxford University has calculated that the probability of human extinction in the next century may be as high as 19%. If civilization collapses in the near term, then Pangea Proxima will form through purely natural processes, just like every previous supercontinent. But if we navigate the current challenges successfully, we might become something unprecedented. A geological force capable of consciously shaping planetary evolution over hundreds of millions of years. And this leads to perhaps the most mind-bending possibility of all. What if conscious guidance of geological processes is actually a natural phase in planetary evolution? What if planets that develop intelligent life are supposed to transition from unconscious geological processes to conscious planetary engineering? Dr. Sarah Seeger from MIT searches for exoplanets that might harbor life, and she's found thousands of worlds where geological processes similar to plate tectonics might be operating. But here's the question that keeps her awake at night: on how many of those worlds has life evolved to the point where it can consciously participate in planetary scale processes? If consciousness capable of geological engineering is a common outcome of evolution, then Earth might be approaching a transition point that has occurred countless times throughout the universe. We might be part of a cosmic process where planets evolve from purely physical systems to consciously directed systems. This would mean that your growing understanding of Pangea and deep time isn't just personal education. It's part of a planetary awakening that connects Earth to processes operating throughout the cosmos. And this sets up the most important question of all: what kind of conscious geological engineers do we want to become? What if I told you that the story of Pangea contains a hidden blueprint for solving every major challenge facing humanity today? And that understanding this blueprint could literally determine whether our species survives the next 100 years, let alone the next 250 million? Here's the mind-bending connection most people miss. The same systemic thinking that explains how Pangea formed, persisted, and ultimately transformed can be applied to understanding and navigating complex modern challenges like climate change, economic inequality, and technological risk. Let me show you what I mean. Pangea's formation involved multiple feedback loops operating on different timescales, tectonic forces operating over hundreds of millions of years, climate systems responding over thousands of years, and biological systems adapting over millions of years. The supercontinent could only exist when all these systems reached a temporary equilibrium. Dr. Donilla Meadows from the Systems Thinking Institute identified this same pattern in modern human systems. She found that sustainable solutions to complex problems always require understanding and harmonizing multiple feedback loops operating on different timescales, individual behavior, community dynamics, economic systems, and long-term environmental constraints. Think about climate change through this lens. Just like Pangea stability required balancing geological, atmospheric, and biological systems, climate stability requires balancing human behavior, economic systems, technological development, and natural environmental processes. But here's what's crucial. Pangea's ultimate transformation wasn't a failure. It was a natural evolution toward a more dynamic, more resilient planetary system. The breakup of Pangea created the dispersed continental configuration that has provided more stable, moderate climates for the past 200 million years. This suggests a profound principle. Sometimes apparent stability is actually rigidity. And true. Resilience comes from embracing transformation rather than resisting it. Dr. C.S. Halling from the University of Florida has spent decades studying this pattern in ecological systems. He's found that the most resilient ecosystems are those that go through regular cycles of growth, conservation, collapse, and renewal, exactly the pattern we see in the supercontinent cycle. Applied to human civilization, this suggests that trying to maintain current systems indefinitely might actually make us more vulnerable to catastrophic collapse. Instead, we might need to consciously design systems that can transform themselves in response to changing conditions. But here's where the Pangea analogy becomes truly powerful. The creatures that survived the supercontinent's breakup weren't the ones perfectly adapted to Pangean conditions. They were the ones with the flexibility to adapt to radically different conditions as the world transformed around them. Dr. Elizabeth Verba from Yale University has studied this pattern extensively. She's found that evolutionary success during major environmental transitions belongs to species with high phenotypic plasticity, the ability to rapidly modify their characteristics in response to changing conditions. For human civilization, this suggests that our survival strategy shouldn't be to optimize for current conditions, but to develop maximum adaptability for unknown future conditions. This means creating educational systems that teach people how to learn new skills rapidly, economic systems that can quickly reorganize around new technologies, and political systems that can make rapid collective decisions when faced with novel challenges. But the most mind-bending insight from the Pangea story involves scale and timing. The supercontinent formed through the slow accumulation of apparently small changes continents moving a few centimeters per year for hundreds of millions of years. But its breakup involved rapid, catastrophic events that transformed the entire planetary system in geological instance. This same pattern appears in human systems. Dr. Nassim Taleb has identified what he calls black swan events, rare but high-impact occurrences that reshape entire systems rapidly. Climate change, technological breakthroughs, economic collapses, and pandemics all follow this pattern of slow buildup, followed by rapid systemic transformation. Understanding this pattern suggests a crucial survival strategy. We need to be simultaneously patient with slow, incremental progress, and prepared for rapid, transformative change. Like the organisms that survived Pangea's breakup, we need to build resilience that can handle both gradual shifts and sudden discontinuities. But here's what's most important. The Pangea story shows us that transformation, even catastrophic transformation, can lead to better outcomes. The breakup of Pangea created conditions that were more favorable for complex life than the supercontinent itself had been. This suggests that many of the challenges we're facing, climate change, technological disruption, economic inequality, might not be problems to be solved by returning to previous stable states, but transitions to be navigated toward new, potentially better configurations of human civilization. Dr. Otto Scharmer from MIT has developed what he calls Theory U, a framework for navigating transformational change that mirrors the patterns we see in the supercontinent cycle. The key insight is that successful transformation requires letting go of current structures, passing through a period of uncertainty and apparent chaos, and then co-creating new structures adapted to changed conditions, applied to our current historical moment. This suggests that the path forward might require consciously releasing attachment to current economic, political, and social structures, while simultaneously developing the capacity to co-create better alternatives. And this brings us to the most profound lesson from Pangea. Transformation is not something that happens to us. It's something we participate in. The question isn't whether change will occur, but whether we'll be conscious, skillful participants in shaping that change. Here's something that will fundamentally alter how you see your daily life. Every mundane activity you do, from drinking a glass of water to sending a text message, connects you to the same planetary scale forces that created and destroyed Pangea. And understanding these connections gives you access to a form of power that most people never realize they possess. Let me blow your mind with a specific example. When you turn on a light switch, you're accessing energy that was originally captured by the forests of Pangea. Electricity might come from burning coal, which is literally the compressed remains of those ancient scale trees and giant ferns. Or it might come from natural gas formed from the marine organisms that lived in Panthalassa, the vast oceans surrounding Pangea. But here's what's truly mind-bending. The act of turning on that light switch makes you a geological agent operating on planetary scales. The carbon dioxide released by burning fossil fuels is altering Earth's atmospheric composition in ways that will influence climate for thousands of years. You're participating in atmospheric chemistry that operates on the same timescales as the processes that regulated Pangea's climate. Dr. Paul Crutzen, who won the Nobel Prize for his work on atmospheric chemistry, has calculated that individual human actions, when multiplied across billions of people, now rival geological processes in their impact on Earth systems. Every time you drive a car, eat meat, or buy something shipped from across the world, you're influencing planetary systems. This isn't meant to make you feel guilty. It's meant to help you recognize the incredible power you actually possess. You're not just a passive observer of planetary processes. You're an active participant with the ability to influence outcomes on geological scales. But to wield this power wisely, you need to understand something that the creatures of Pangea never could: how individual actions scale up to systemic effects. Think about how Pangea's climate system worked. Individual forests absorbed carbon dioxide and released oxygen. Each tree was just doing what trees do, photosynthesizing to survive. But collectively, these individual biological processes regulated atmospheric composition for the entire planet. The same principle applies to human civilization. Individual humans making conscious choices about energy use, consumption patterns, and lifestyle create collective effects that can stabilize or destabilize planetary systems. Dr. Elinor Ostrom, who won the Nobel Prize in Economics, spent decades studying how individual actions can be coordinated to manage shared resources sustainably. Her research revealed something crucial. The most effective solutions to collective challenges emerge when individuals understand both their local impact and their connection to larger systems applied to your daily life. This means that every choice you make carries two levels of significance: its immediate effect on your personal situation and its contribution to planetary scale patterns that will influence conditions for generations. But here's what's most empowering: understanding. Your connection to geological processes doesn't just give you responsibility, it gives you resilience. When you truly grasp that you're part of systems that have survived the formation and destruction of multiple supercontinents, it changes how you respond to everyday challenges. Dr. Viktor Frankl, who survived the Holocaust and founded logotherapy, discovered that people can endure almost any hardship if they understand its meaning within a larger context. He found that individuals who could connect their immediate suffering to larger purposes were more likely to survive extreme conditions. The same principle applies to understanding your place in geological time. When you realize that you're part of processes that have been operating for billions of years and will continue for billions more, it provides a form of perspective that can transform how you navigate personal difficulties. Every challenge you face, job stress, relationship problems, health issues, financial concerns, becomes manageable when you understand it as a brief fluctuation within the vast, resilient systems that created your existence in the first place. But the most profound realization involves understanding that your consciousness itself is part of the Earth system's evolution toward greater complexity and awareness. Dr. Pierre Teilhard de Chardin called this the noosphere, the sphere of human thought that now envelops the planet like a new geological layer. Your individual thoughts and decisions contribute to this collective intelligence that is increasingly capable of understanding and potentially directing planetary evolution. Every time you learn something new about Earth systems, every time you make a choice based on understanding of long-term consequences, you're participating in the development of planetary-scale consciousness. This means that your fascination with Pangea, your growing awareness of deep time, your sense of connection to geological processes, all of this is part of the Earth system developing the capacity for conscious self-direction. And this leads to perhaps the most empowering realization of all. You're not just living through a random moment in cosmic history. You're participating in what might be the most significant transition in Earth's 4.6 billion year evolution, the emergence of conscious, planetary intelligence capable of guiding its own development across geological timescales. Your daily choices matter not just for your immediate well-being, but for the kind of conscious planetary system that emerges over the next few million years. What if I told you that everything you've learned about Pangea points to one inescapable conclusion? Humanity is about to face a test that will determine not just our survival, but our evolutionary trajectory for the next hundreds of millions of years. And the outcome depends entirely on choices we make in the next few decades. Here's the mind-bending reality. We're living through Earth's most rapid transition period since the asteroid impact that ended the age of dinosaurs. But unlike previous mass transitions, this one is being driven by a conscious species, us, which means the outcome isn't predetermined by purely physical forces. Dr. Johann Rockström from the Potsdam Institute has identified what he calls planetary boundaries, 9 Earth system processes that regulate the stability of the planet's environment. His research shows that human activity has already pushed 4 of these systems beyond safe operating limits, and we're rapidly approaching tipping points in the others. Think about this through the lens of Pangea. The supercontinent existed within stable planetary boundaries for tens of millions of years. But when those boundaries were crossed, through massive volcanic activity and atmospheric changes, the entire Earth system rapidly reorganized into a new configuration. We're approaching a similar reorganization point, but with a crucial difference. We understand what's happening and potentially have the power to influence the outcome. But here's what makes this moment truly unprecedented. The timescales of human decision-making and geological processes are converging. Climate tipping points, biodiversity collapse, and other planetary boundary crossings operate on timescales of decades to centuries. Fast enough that individual human choices can influence outcomes. Dr. Will Steffen from the Australian National University has called this the Great Acceleration, a period when human influence on Earth systems has accelerated to the point where we're operating at nearly geological speeds. This creates both enormous opportunity and terrifying risk. If we navigate this transition successfully, we could create a planetary system that's more stable and supportive of complex life than anything in Earth's history. But if we fail, we could trigger a collapse that makes the end of Pangea look gentle by comparison. The key insight from the supercontinent cycle is that transitions between stable states always involve periods of apparent chaos and instability. Dr. Ilya Prigozhin won the Nobel Prize for demonstrating that complex systems often have to become more chaotic before they can reorganize at higher levels of complexity and stability. Applied to our current situation, this suggests that the turbulence we're experiencing, climate instability, economic uncertainty, political polarization, technological disruption, might not be signs of impending collapse, but signs of a system preparing to reorganize itself at a higher level of functioning. But successful reorganization requires what Prigozhin called dissipative structures, organizational patterns that can maintain coherence while adapting to rapidly changing conditions. In biological systems, these are organisms that can rapidly modify their metabolism, structure, or behavior in response to environmental changes. For human civilization, this means developing social, economic, and technological systems that can rapidly evolve in response to changing planetary conditions. We need governance systems that can make collective decisions at the speed of environmental change. We need economic systems that can rapidly reorganize around new energy sources and resource constraints. We need educational systems that can help people develop the cognitive flexibility to adapt to constantly changing conditions. But here's what's most crucial. The window for conscious choice in this transition is rapidly closing. Dr. Hans-Joachim Schellnhuber from the Potsdam Institute has calculated that we have perhaps 10 to 30 years to implement changes that will determine the trajectory of planetary systems for the next 1,000 years. This means that the choices made by your generation, the energy systems we deploy, the economic models we adopt, the international cooperation we achieve or fail to achieve, will echo through geological time. Like the volcanic eruptions that ended the age of Pangea. Think about the incredible responsibility this represents, but also the incredible opportunity. You're living at the one moment in Earth's history when individual human choices can influence the trajectory of planetary evolution for hundreds of millions of years. If we succeed in creating sustainable, regenerative systems that work within planetary boundaries, we could initiate a period of conscious planetary stewardship that continues until the next supercontinent begins to form. Future humans might look back at this moment as the beginning of Earth's transformation from an unconscious physical system to a consciously directed living system. But if we fail, if we cross too many tipping points and trigger irreversible changes that undermine the stability of Earth's life support systems, then the next supercontinent might form on a planet that can no longer support complex life, let alone technological civilization. The creatures of Pangea had no choice in their transition. They were subjected to changes driven by purely physical forces. But we do have choice, which makes us either the most powerful or the most dangerous force in Earth's history. And this brings us to the ultimate question that the story of Pangea poses for every human alive today. Will we use our unprecedented power to create conditions that support the flourishing of life across geological timescales? Or will we become the force that ends the 3.8 billion year experiment of life on Earth? So here we are, at the end of this incredible journey through deep time, and I want you to take a moment to fully absorb what you've discovered. You began this video thinking you were going to learn about an ancient supercontinent. But what you've actually discovered is your own cosmic significance and the incredible responsibility that comes with being conscious during Earth's most crucial transition period. Let me tie together all the mind-bending revelations we've explored and show you how they point toward one inescapable conclusion. You are not just a random observer of cosmic processes. You are an essential participant in the most important chapter of Earth's 4.6 billion year story. Remember how we started with the shocking realization that the ground beneath your feet has traveled thousands of miles from its position during Pangea. But now you understand that this isn't just a curious geological fact. It's a metaphor for your own journey through cosmic time and space. Not every atom in your body has been recycling through Earth's systems for billions of years, participating in the formation and destruction of multiple supercontinents. Your consciousness, your ability to contemplate these vast processes, represents the latest evolution of the same. Energy flows that created Pangea, tore it apart, and have been shaping our planet ever since. We discovered that Pangea's extreme climate created evolutionary pressures that drove life to develop capabilities that still benefit organisms today. The biochemical innovations, survival strategies, and adaptive mechanisms that first appeared during the supercontinent period became the foundation for all subsequent evolution, including the evolution of human intelligence. This means your capacity for consciousness, your ability to understand deep time, your sense of wonder at geological processes. All of these emerged from the extreme conditions that Pangea created. You are literally thinking with neural networks that evolved from the challenges of supercontinent life. We explored how the supercontinent cycle operates as Earth's long-term climate regulation system, preventing our planet from becoming either too hot or too cold to support complex life. This regulatory system has maintained habitability for billions of years, creating the stable conditions that allowed consciousness to evolve. But we also discovered that this regulatory system now includes human consciousness as an active component. For the first time in Earth's history, the planet has evolved a species capable of understanding and potentially guiding the very processes that regulate habitability. This means you're not just benefiting from Earth's regulatory systems, you're becoming part of them. Your choices about energy, consumption, technology, and cooperation now influence planetary systems that operate on geological timescales. But we revealed that the next supercontinent, Pangea Proxima, is already beginning to form through processes happening right now. The collision between Australia and Asia, the closing of the Atlantic, the subduction of the Pacific, all of these are early stages of the next great continental assembly. But unlike previous supercontinent formations, this one will be influenced by conscious choice. Humanity has 250 million years to develop the wisdom and technology necessary to participate consciously in this process, rather than being subjected to it passively. We explored how the same systemic thinking that explains Pangea's formation and transformation provides blueprints for navigating complex modern challenges. The supercontinent cycle demonstrates that apparent stability often masks underlying rigidity, and that true resilience comes from embracing conscious transformation rather than resisting change. This suggests that many current global challenges aren't problems to be solved by returning to previous states, but transitions to be navigated toward new, potentially superior configurations of human civilization. Most importantly, we discovered that you possess a form of temporal consciousness that no creature in Earth's history has ever had: the ability to simultaneously exist in the present while being aware of processes operating across millions of years. This geological intelligence might be humanity's primary evolutionary adaptation for navigating planetary scale challenges. But with this unprecedented cognitive capability comes unprecedented responsibility. You're living at the moment when individual human choices can influence the trajectory of planetary evolution for hundreds of millions of years. The window for conscious choice in Earth's current transition is measured in decades, not centuries. The energy systems, economic models, and international cooperation we achieve in the next 10 to 30 years will determine whether Earth becomes a consciously directed living system or experiences a collapse that could end the 3.8 billion year experiment of complex life. This means that every choice you make, how you use energy, what you consume, how you vote, what career you pursue, how you raise your children, what values you embody, contributes to the most important collective decision in Earth's history. You are not a passive observer of this process. You are an active participant whose individual choices combine with billions of other individual choices to determine the outcome of planetary evolution. The creatures of Pangea were subjected to forces they couldn't understand or influence. But you have both understanding and influence. You know what's happening, and you have the power to affect outcomes. This gives you something that no previous generation in human history has possessed: the opportunity to consciously participate in designing the future of Earth across geological timescales. Whether Earth becomes a consciously stewarded living system that supports the flourishing of life for hundreds of millions of years, or experiences a collapse that ends complex life forever, depends on choices being made right now by people like you. So as you go forward from this moment, remember, you're not just living a human life on a rock in space. You are consciousness emerging from the Earth system itself, equipped with the understanding and capability to guide planetary evolution toward outcomes that honor the incredible 4.6 billion year journey that created your existence. You are Earth, becoming aware of itself and developing the capacity for conscious self-direction. Your thoughts, choices, and actions matter on cosmic scales because you are part of the cosmic process of consciousness emerging from complexity. The story of Pangea isn't ancient history. It's the backstory to the most important chapter still being written, and you are one of its authors. Before you go, hit that like button if this journey through deep time has expanded your sense of what's possible. Subscribe for more reality-expanding content. Share this video with someone who needs to understand their cosmic significance. And tell me in the comments, now that you know your connection to Pangea and your role in Earth's future, what will you do differently? Because the future of our planet literally depends on how you answer that question. Next supercontinent is forming. The question is, will it be consciously created by descendants of the species that learned to think in geological time? Or will it form on a planet where that experiment failed? You get to vote with every choice you make for the rest of your life. Choose wisely. The Earth is counting on you.